So they don't clearly express this here, but it's really all of this is inside a logarithm. All of this is inside the argument of the logarithm. So to solve these, look, a log of something equaling a log of something, we can use the one-to-one property of logarithms, which all that means is that, hey, if these two sides are going to equal each other, then this better equal this. You better get the same numbers out of it. 12 times x plus 5, that's got to equal 4 times 6x. That's a much easier equation to solve, right? Distribute the 12, multiply 12 to everything on the inside, multiply that 4, subtract that 12x from both sides, and then divide 12 from both sides. 12 to 4 to 6, 4, 8, 56, that's 5. So x equals 5 is our solution, okay? And then we can do the same thing for this one, except right now it's not one logarithm equals another logarithm. It's log base 3 of this times this. We can use the product rule of logarithms. If you have two logs with the same base adding to each other, then that's the same thing as the product of those two things, x plus 5 times x plus 1. Okay, that's the key to this problem. Now it's just like that last problem, where if these two sides are going to equal each other, then this better be the same as this. So x plus 5 times x plus 1, that should equal 21. So we can we can multiply those together. Some students remember FOIL, when you multiply two parentheses together. So plus x plus 5, so that's plus 6x plus 5 equals 21. This is quadratic, so that means you usually want to set a quadratic equal to 0. So subtract that 21 from both sides. And then let's see if we can factor. That would make it solving easier. Otherwise, you could use the quadratic formula. But we want to see if there's two numbers to multiply, it'd be negative 16, but add up to be 6. And if we can find them, then we'll start off two new parentheses with x. That way x times x will make x squared. And that way the middle terms add up to make 6x. So the terms are positive 8 and minus 2, because 8 times negative 2 makes negative 16. 8 plus negative 2 makes 6. And the last step, how are you going to make this equal to 0? Well, if you put in negative 8 to this parentheses, negative 8 plus 8 is 0, and then 0 times everything over here is going to make this whole left side equal to 0. And the other one, if you plug in 2 in for x, 2 minus 2 makes 0, and then 0 times everything over here is going to make 0. So those are our two solutions. Sorry, so I made a mistake. This is, I think, going to be the only solution, not this one. The reason is because if you plug negative 8 back into this original expression, negative 8 plus 5 is negative 3, and you can't evaluate a logarithm of a negative number. Okay? In other words, there's no power you can raise 3 to be to turn it from positive to negative. So watch out for that. The argument can't be negative in the logarithm, so that's why I had to exclude negative 8. Sorry, I forgot about that.